Hi, welcome all. In this video, we shall be discussing about solving second order differential equations using Euler's method. Okay, let's recall Euler's method, and please remember that Euler's method is used for solving first order differential equation. Y dash is equal to f of xy. You will be given at x is equal to x0, y is equal to y0. Okay, you can calculate the new value of y, like yr plus 1 is equal to yr plus h into f of xr yr, where and xr plus 1 is equal to xr plus h. So this way you can find out the new values of y's and x. Now the problem is this. In physics, we often come across second order differential equations. For example, if you consider simple harmonic motion, it is such a simple harmonic oscillators are characterized by this equation: d square x by dt square plus omega square x equals 0. Or if you consider a freely falling body, it's characterized by its acceleration is negative 9.8. This is basically a differential equation. If the body falls along the y-axis, then the acceleration may be represented as d square y by dt square is equal to minus 9.8. Okay, so this is actually a problem. Almost all cases, in almost all the physical systems are characterized by second order differential equation. So this makes the problem. So how do we solve such a problem? The idea is really simple. You will have a second order differential equation. You will have a second order differential equation. You resolve that into two first order differential equations, solve, and then you solve these two equations simultaneously. So we know how to solve a first order differential equation. If you have a second order differential equation, the idea is really simple. You just split that into two first order differential equations. So we'll explain the procedure through some example. So let us first choose a freely falling body. So let us describe the problem like this. Let us choose y-axis as the axis of motion and ground as the origin. Okay, at t is equal to 0, so initially say at t equal to 0, the body is somewhere here, right? So you can say that its y coordinate is just h. So where we have choose this as the positive direction for y-axis. So this is my y-axis. So y is equal to h at some height. Okay, and at that point the velocity is equal to 0. Fine. So this is the initial condition. Okay, so this is the initial condition. You know initially what it is. Now the problem is this: at some t, say 0.1 second, what is the position and what is the velocity? We wish to know this thing. And at t is equal to 0.2 as well, we must know what is y and what is its velocity. So this way you can calculate the new y values and new v values means position value, position and velocity at every instant as long as it reaches this ground. Okay, so this is called basically simulation. And how you can solve this? You basically, the step is this: you represent freely falling body by a differential equation, that is its acceleration is negative 9.8. So you can rewrite this equation as d square y by dt square is equal to negative 9.8. Now the idea is this: we must resolve that into two first order differential equations. And for that, let me substitute what dy by dt is. You know, dy by dt is nothing but rate of change of position, that is velocity. With this substitution, let me call this as equation number 1. With this substitution, the second equation will change as d square y by dt square can be written as d by dt of dy by dt, that is dv by dt. dv by dt equals minus 9.8. So this is my second equation. So solving this equation, solving equation 1, solving equation 1 will give you new value of y, correct? So gives evolution of y with respect to t time. And solving equation 2 gives evolution of time evolution of velocity. So this point is really important. Okay, so solving this equation, you will get the new value of y, and solving second equation, you will get the new value of v. Now how you solve this? So we define f1 of x, as, what is f1 of x? V. Or exactly speaking, sorry, I made a mistake. It's not f1 of x. You call the function as f1. The independent variable is t. The dependent variables are y and v. So it could be, in general, can be function of 3 variables, correct? But here it is only a function of v itself. But for definiteness, let us write like this. And for the second equation, you can have f2. There also the independent variable is t, then y and v, which is equal to minus 9.8. Okay, but really speaking, this is a constant. But in general, for any differential equation, you can write something like this. Okay, so you have two equations. Now at t is equal to 0, we know the initial condition for both. So initial condition to begin with, we know that at t equal to 0, your y is equal to h and v is equal to 0. Now how can you find the new y position? That formula is really simple. Your y is equal to previous value of y plus h into the time step into f1 of t comma y comma v. So this will give you the new y value. Solving second equation will give you the new v value. So how can you write? New v is equal to previous value of v plus h into, here h is the time step, into f2 of t comma y comma v, correct? And once you calculate the new y value and new v value, you must calculate the new time, t equals t plus h. Okay, so so this set of 3 equations must be iterated to get the new y values, means position values as well, and new velocity values. Okay, hope you understood the idea. So this is basically a problem to be discussed, so we shall think of the Python code for that. Okay, so let me recall the steps involved. The basic idea is this: resolve the given differential equation into two first order differential equations like we have done here. So this is the first differential equation, this is the second differential equation. Now solve these two equations simultaneously. How you solve this? You will have some initial conditions at t is equal to 0, y is equal to h, and b is equal to 0. So what we do is we repeatedly calculate the new position, new velocity, and new time until it reaches the ground. So this way we can simulate. Thus we have discussed how a second order differential equation can be solved using Euler's method. Okay, we took the example of a freely falling object, a Python simulation using Python code, and the algorithm involved will be explained in another video. That video will be titled as section 5, first video, simulation of freely falling object. So please watch that for Python code. Thank you.